Is this the answer to Tesla's Optimus? Today on AI News, we're breaking down the new preview of the KAI Humanoid, a machine that doesn't just mimic humans, but is actually learning to feel like them too. From the world's first 36 degree of freedom dexterous hand to a brain that dreams of its own future, we're unpacking 6 critical layers that make this robot unique, starting with its form factor. As the KAI Humanoid stands at 173 centimeters tall or 5 feet 8 inches and weighs 70 kilograms or 154 pounds, and it features a human equivalent range of motion with a 115 degree of freedom framework across its entire body. In fact, the upper body alone accounts for 26 degrees of freedom excluding its hands, which are a world's first of their own. So here's where it gets really interesting. KAI features 1-to-1 human scale hands with 36 degrees of freedom each, but the breakthrough is that 22 of those joints are active, meaning driven by motors, while its other 14 degrees of freedom are passive or compliant. This means the hand can naturally mold its shape around objects just like a human hand does, all without needing a motor for every tiny knuckle movement. And it's powered by a world-first hybrid drive system that combines the raw strength of direct drive with the precision and muscle-like flexibility using what's called tendon-driven technology. Then, for structural integrity, it's designed with a thermal force balance and a unidirectional self-locking structure for continuous load-bearing grasping, all without using an excessive amount of power, so it can just lock and hold an object. And the robot's exterior is adaptable, featuring an integrated multi-form design, allowing for different outer skins and shells that are suited for different scenarios, like service or industrial use cases for instance. But having a 1-to-1 human shape is only half the battle, because to truly work alongside humans, KAI can't just look like a person, it has to feel like one too. And this is where KAI's massive sensory network comes into play. So it features a high-density sensory network that's embedded with over 18,000 tactile sensing points. And as for precision, each sensor features a tactile resolution of 0.1 newtons, allowing it to detect even the slightest pressure for a truly human-like sense of touch. And over 80% of KAI is covered with this sensory skin. But all this sensory data and mechanical complexity requires a serious amount of power to keep it moving. So to solve the endurance problem that plagues most humanoids, the team went straight to the next generation of battery tech. And they did this using a customized 1.7 kilowatt-hour semi-solid state battery platform for maximum safety and energy density. And as for its operational range, the battery achieves over 3 hours of endurance and manages a 20 kilogram dual-arm payload, which is equal to about 44 pounds. And this is possible because of the use of custom actuators. Specifically, these are high-performance, low-friction, low backlash actuators to enable whole-body compliant control, meaning the robot can react safely to external physical force. But besides the body, skin, and power, how does the robot actually decide what to do with all this? That's where its brain comes into play, which is capable of predicting the future using the new KAI World model. So to make this all possible, KAI uses a closed-loop 3-step architecture that turns raw data into intelligent action. So first, it starts with its world simulation model, which simulates real physical dynamics to imagine the future results of candidate actions. Second, KAI's world action model proposes the next action based on the current state, which is constantly updated by value feedback. And third, KAI's world value model acts as the critic. Its job is to score the imagined rollouts and then send that information back to refine its action policy. And by running this internal loop, KAI gains 2 critical capabilities. The first is action visualization, which is the ability to predict and see the results of an interaction before it even happens. And second is autonomous world exploration, which is the ability to independently navigate and learn the physics of a new environment all without human intervention. But an AI brain is only as good as the data you feed it. So to make KAI even smarter, its developers didn't just scrape the internet. They also built a custom hardware pipeline to see the world exactly as humans do. Enter KAI Halo and the Ego dataset, which both feed KAI's world model. First, there's KAI's Halo terminal. This is a wearable data headband used by humans to collect first-person data. It captures dual ego views with synchronized binocular video, 3D scene reconstruction using real-time point cloud mapping of the room, whole body joint curves for accurate tracking of human joint movement data, and semantic annotation for real-time labeling of actions. In fact, the Ego dataset has over 100,000 hours of video, 30 million clips, and 300 plus atomic skills covering 20 plus scenarios. So that's the hardware, brain, and data, but how do you actually turn all that info into a robot that can cook, clean, and work? Well, this all comes down to a precise 3-stage training evolution, with the first stage being pre-training, where KAI learns foundational physics and human behavior from massive internet-scale egocentric data. The second stage is mid-training, where KAI refines its specific motor skills, like manipulation and task execution, using high-fidelity simulation data. And the third and final stage is post-training, which is the final optimization using KAI's proprietary Ego dataset. This data is captured by the Halo terminal to bridge the gap between simulation and the real world, ensuring maximum reliability. And according to Kinetics AI, KAI is eyeing a 2026 rollout, but that brings up two massive questions. First, what is the price tag for 115 degrees of freedom and semi-solid state batteries? Can this actually be affordable? And second, the elephant in the room with any new humanoid reveal, are we looking at a genuine proof of concept robot performing these tasks autonomously, or is this just another case of teleoperation, or even a human in a green screen suit with a digital overlay? Let us know what you think in the comments below. Is KAI the real deal? But instead of having a proprietary robot, Asimov just released their open source V1 robot that you can build yourself and train on. And as for specs, it stands 1.2 meters tall, weighs 35 kilograms, and features 25 actuated degrees of freedom, with all of its structure being machined out of 7075 aluminum, as well as components 3D printed in MJF PA12 nylon. So as of yesterday, they just released their mechanical design and simulation files, with the robot being ready for locomotion policy training out of the box. And as for its price, it's going to cost $499 for the deposit, with a $15,000 target range price, and it's going to start shipping at the end of this summer in 2026. But tell us down below which you would prefer, proprietary or open source. Anyways, like and subscribe, and check out these videos here for more of the latest in AI and robotics news, and thanks for watching.